In this video, we're going to take a look at first order partial derivatives using the chain rule, and then we're going to start to say, okay, well, what do second order partial derivatives look like? So here I have a function of two variables, z equals f of xy, and here we have x squared plus 2xy to the fifth power. I, first of all, would like to find the first order partial derivative with respect to x. So, okay, here I want the first order partial derivative with respect to x. So I'm treating y as a constant here, but I have perhaps a slight issue. Here I have x squared plus 2xy, which is a function of x, inside of this x to the fifth power right here. I actually have a function inside of a function. So this is going to require our chain rule. So perhaps we'll take a second to rewrite this. We'll say, okay, I'm going to pick that inside part just like I did with the chain rule before. U is equal to x squared plus 2xy. We say, okay, if we have u, we generally need u prime, but here u prime is not particularly clear since we have the partial with respect to x or the partial with respect to y. So instead, I'm going to write u sub x here, the partial with respect to x. So u sub x, this is, let's see, here derivative of x squared, that's just going to be 2x. Derivative of 2xy, remember we're just going to pretend like that y isn't there for right now. The derivative of 2x, that's just going to be plus 2 times, well, y is a constant multiple, so I just multiply the derivative by that, so times y. So here is the derivative of the inside part with respect to x. So I'm going to take a moment to rewrite this. This is f equals, I'm just going to write f. This is really, u to the fifth power. So when I take the partial derivative with respect to x, we'd say, okay, the derivative of this part right here, well, that's 5u to the fourth power times, normally we would say u prime, but we said, okay, instead we're going to say times u sub x, the partial derivative with respect to x. So now I just need to take my u and the derivative of u and plug those back in. So I'm just going to take these guys and plug those back in over here. So let's see, this is really 5 times x squared plus 2xy raised to the fourth power times u sub x. U sub x is 2x plus 2y. I would probably just leave my answer exactly like this. If you really wanted to, you could take this 5 and distribute it to these two terms over here. You cannot distribute it to these two terms right here because of this exponent of a 4, so just be very careful. Generally, I'm not really going to simplify these anymore. Similarly then, if I want the partial derivative with respect to y, it's going to be a very similar process here. So again, let's just write our function so that we have it in front of us. This is x squared plus 2xy raised to the fifth power. So again, I see this function here, which is x squared plus 2xy. As soon as you see that y, you know that we're going to have a chain rule here because it's inside of this x to the fifth power. So you may need to, if you need to, off to the side, say u, well, that's equal to that inside part, which again is x squared plus 2xy. And here, here I want the partial derivative of u with respect to y. So u sub y, x squared, that's a constant. So the derivative of x squared, that's going to be 0. Plus here, ignore 2x for a moment, the derivative of 2y, that's just going to be plus 2. And then that x, it's a constant multiple, so that just comes down to the next step, so 2x. So the partial derivative with respect to y is simply 2x. So if you need to, we can rewrite this. This is f equals u to the fifth power. So let's see, f sub y, this is 5u to the fourth power times u sub y. Notice that when you use the chain rule, the overall structure of these is going to be the same. The derivative of that u part doesn't actually change. It's the derivative of the inside part, u sub x versus u sub y. That's where the difference is going to happen. So here, 5 times u to the 4th, u was x squared plus 2xy raised to the 4th power, times u sub y, that is just 2x. If you really wanted to, you could multiply 5 and 2x. You could say 10x times x squared plus 2xy to the 4th. I think either one of these is perfectly fine. Of course, you don't have to show all of this work. You can take, a little bit of a shortcut here. But this is, I just wanted to take this process, draw it out, just because this is a new idea, this applying the chain rule to functions of several variables is not something that we're used to dealing with. So take your time with these problems. There's probably only a couple in the homework exercises, but I think they're good practice.